Yo, what's up, everybody? So, right now we are just recording this problem. Don't know if my OBS is lagging or what. Let's see. So, I'm solving this problem. It code 473, where you are given an integer array matchstick. The matchstick y is the length of the I. Want to use all the match square, and you should not take any stick. Okay, that means we have to use the complete stick. By the way, you can link them up. Each match must be used at okay. So this is the size of the matchstick array that is given to us. And first of all, like oh freaking shit. So I just like this is the array that is given to us, and we are gonna make. You can see that the total of this array is 8, which is equally divisible by into 4 sides of 2 to 2 each. And this thing 1 1 has summed up as side side 2. This is 2. This is 2. And this is 1 1. So when we sum it up, we will get a 8. That is the total of this matchstick. And here you can see that the summation of this array is totally 16, which gives us a hint that this total can be divided into 4 4 4 4. But yeah, 4 4 4 4 4, totaling up to 16. But that is not the case because we get a perfect 1 4 side. Okay, but here only we have threes only, so we cannot make 4 4 4 like the other three sides, so we return a false. And coming at this problem, you can see that the constraint is 10 power like 15. So it basically gives us the hint that this problem is for sure backtracking problem. And the backtracking, you can have 2 power n, so n is 15, so maybe it's 4 power 15. That will be close to 2 power 30. Yep, like 4 power 15 can go. And that will be simply somewhat like 2 power 30. And in LeetCode, we know that 2 power 30 is somewhat similar to the 10 power 8 thing. Like 2 power 32, it's similar to 2 power 32, and 2 power 32 is somewhat similar to 10 power 8. So it's giving us hint that we're gonna use this thing. This is the backtracking. So it will have maybe probably 4, and this is some stupid. So it's probably 100% a backtracking problem. And the topics also, you can see that backtrack there, and dynamic is there if maybe we will be needing some kind of memoization for the overlapping sub problems at the recursion of the backtracking that we will get. And these are the hints. Hints are just saying that do this, do that. For it's basically a backtracking problem. What have I done till now is I have calculated the tot. Tot is the total summation of the array of this array. Like for this one, the tot is 1 1 1 2 2. So the summation is 8. If the summation is not divisible by 4, straight up return. Yeah, and this is the side length. This would be the what each side should look like. Now we need to know. Okay, so and one more thing, if any of the element in this array goes more than the side length, it is total by 4. Let's say here we have something like 3 5 comma 4, 5 comma 3, like it would be something like oh no. Okay, yeah, let's say it would be like 3 3 3, and a 5, a 3. The summation is still 16. A 12 plus 4. Ah. Hmm. Yeah. Let's say if the array was looking like this, the total we are getting is still 16, but we see a side that is 5 that is greater than this. So it will be a very big side. So we cannot fit it somewhere because we cannot break it. So we straight up return a false if we see a super large stupid side length present in the matched array. And here what I'm saying is this is kind of a recursive state. A, B, C, D are side lengths, and I is index of array traversal. Yeah, that would be the thing. Here you can see I defined it. Define f of comma b comma c b comma I, and if we reach the last thing, we'll just return if some summation we were able to do something like A equal b equals c equal d. So four sides are equal. We're able to do or not, and m is the size of this metric. Like m value would be 1 1 2 2, like traversing it. I'm using array of I have used array as ARR as the array instead of this matchsticks that was previously given to us in the question. And let's simulate this. And first I will be putting it up into the, what you say, a plus m is less than equal to side. This side thing we have already calculated, and and we are calling the recursive function that is a plus m comma b comma c comma I. I'm gonna do it if this thing returns true. Return true. Similarly, I will be calling it up for the other things. How much we got? We got 4 a plus. So now we are putting it in the b thing. When we are putting it onto the b thing, I will be using b plus m, and I will be I plus 1. My bad. Okay. It would be a b c d plus a b. And yup, everything fine. Very good. Yup, this would be c the same. D less than equal to side. All right. If none of these were giving us a true value, then we will return a false. Now let's call f of 0 comma 0 comma 0 comma 0, calling the define recursive. Let's see what breaks down. Invalid syntax where. Okay, 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 my bad. I was using equal name n is the length of array. Let's see. Oh, it returned null. And just work. What the fuck? Up. And if false, what am I missing? Yo, it was N. Was N. Had to go till N. And we don't need this bullshit. We just need to return simply. We will just put a return here. We don't need this. See, let's see, let's see. Okay. Yep. This is the DP thing that is happening. And maybe we can sort this array in the reverse thing. This will help with this will be this will be helping with the what you say, the depth of the tree will be chopped priorly in startingly also. Let's like we can see 4 is there. So for 4 next thing will be 3. So 4 plus 3, this thing will never execute. Like this tree will never execute. So in that way, for all the larger things we are processing first of all, this is some kind of. And let's see if something is broken, or let's set giving TLE. Yo, it got passed. We made it up. It's giving us a runtime of 1576 milliseconds. That is a lot. I guess we can use a cache thing. Let's see if this putting this cache thing inside the Python, which makes it up a manual memoization DP thing. Will it help in the time complexity? It helped. It helped a lot. It's only 339 milliseconds. This DP thing makes it super fast in memoization thing. Ooh, yo. So this was the entire crux. And furthermore, what we can do is we can just simply, oh no, and yup, we can make it make it just look little bit cleaner. Elif would make it better. This is the base case greater than see. Let's see. What the fuck? Oh, this too. I don't know what this else thing was doing. And I don't like these two. I will use if only. If the best. But I've seen somewhere I get stuck with elif also. Okay, okay. This check was needed. All right. So once again, coming up to the approach, what we did was we calculated the n is the length of array total was the total of the summation. If total was not divisible by 4, that is, it cannot be divided into 4 pieces. So we just straight up written a false. And we calculated the side length that would be total divided by 4. And for every element in the array, if some element is greater than this side length, that means that this is super big. So we just straight up written a false thing. And we used array dot sort reverse equal true because we are putting up these checks, and only after these checks are passing, these inside recursive calls are going only after these checks are passing. So we can make the recursion depth go stop even before, like a way to make it whatever it is gonna fail, like a tree is here, here, it will fail here. So instead of failing here, we will just check it is failing the top only. So we are using a array dot reverse equal true, and we are using a memoization using the man is cache dp on this thing that's working, and we are calling it up. That's the entire crux. Got it. So this is the part one solution. There is another solution for this. Let me code it up real quick. So what we are going to do is we'll need a size array. There will be 0 star 4. All right. And we'll be doing a backtracking thing. We will be using a single define f of I. This will be the backtracking thing. If I equal minus 1. All right. I is great. I equal n. E return sum of sides. What was it? Total. For j in range. I saw it on the code thing. This solution. For j in range 4. Okay. If sides of j plus m, the array of I, that is the matchstick, less than equal to side, we are calling the recursive function of I plus 1 return true. Like this thing was not working, so we will just backtrack. Backtrack and what we need. And true. If nobody is returning true, return false maybe at the end. I don't know. And we are calling a return of f0. So what I will do is I will just move this thing. Yup. And I will just okay, sides, okay. Okay. Let's run it. It might fail some. Yo, it worked. It is working. This backtracking code also is working. So we got the another second approach also. What the? Where did it fail? Why did it fail? Else won't be else. It won't be else. I think I should put it where here. Will gonna work on. No man. Wrong here. The neat code. What the fuck? Matchsticks. Will it work? Will it work or not? I don't need this match check here. I don't need this thing. Yo, we got it. Got it, bitch. Got it. Make it work. Vamos a la playa. A mí me gusta bailar. Alone. I am doing the sword equal reverse thing. Why the fuck is this thing not working? Pruning is needed. A pruning is needed, man. I was doing this pruning thing. I'm doing this. Else I'm doing this. Adds over a equals 0 break. White. Let's try. And the for loop will exit. We will the DFS of good work. Vamos a la playa. A bailar. We got it. Got it. Got it. Vamos a la playa. Me gusta bailar. Sure. So that is the all we have to say for this thing. And I would like to tell you that watch a YouTuber called Timo Cheng, and Neat Code is the code, and Elite Code, another good YouTube channels that I watch. Bye bye. Let me set it up. Send it. Working. It. Both of the approaches are working, and this solution is uploaded, and this will be it. This will be it for this problem. I'm gonna sync it to my GitHub. So I can have this solution saved up properly my GitHub drive. So that's all for this problem. I'm gonna end this video here only. All right, thanks.